Number 10, airplane flying 200 miles an hour with respect to the air. It needs to fly to a point 600 miles due north. The wind's coming from the west at 60 miles an hour. How long will it take the airplane to complete its flight? So obviously relative motion problem. The general equation we have talked about is the velocity of the plane with respect to the ground is equal to the velocity of the plane with respect to the air plus the velocity of the air with respect to the ground. So this is the wind, this is the airspeed, okay, and this is the actual speed. Okay, and we need to relate that to the displacement. And so we can calculate the time. Let's draw a picture here. We want to fly 600 miles an hour, 600 miles due north. Okay, so that's going to be the plane with respect to ground. Okay, that's how far we want to actually fly, and that's 600 miles. And we don't know the actual velocity of the plane with respect to ground. Alright? So, that vector is going to be the addition of these two other vectors. Let's draw the wind first. Okay, the wind's coming out of the west. So here's north, south, east, west. Okay, so if the wind's coming out of the west, draw this as a vector because that's where we want to go, to the north. If the wind's coming out of the west, I can draw this one of two ways. I'm going to draw it up here. And I could also draw it down here as well. But there's my out of the west direction. That's the air with respect to the ground. We know its velocity, 60 miles per hour. Okay, and so the question really is what direction do we have to head? Okay, this is going to be the plane. Write that. The plane with respect to the air. We know its velocity is 200. Okay, but we don't know its angle. But we know it's in that direction. So we need to head sort of northwest and allow the wind to blow us back to the east because the wind's coming from the west, and this is our effective displacement and velocity. Alright? So the trig in this particular problem is pretty easy because we have a vertical and a horizontal part of our triangle here, and so we can use Pythagorean theorem. The 200 is actually the hypotenuse, so, and this is a right angle in here, so we know that 200 squared is equal to 60 squared plus the velocity of the plane with respect to ground squared. So velocity of plane with respect to ground, trying to calculate that, is going to be 200 squared minus 60 squared, and the square root of that. 190.8. Okay. Keep getting a stray mark here, I guess, for moving that calculator. Okay, so velocity of plane with respect to ground. The length of this vector in the velocity diagram is 190.8. We know we're going to need to go 600 miles, so velocity is distance over time. So time was distance over velocity. Okay, so our 600 miles divided by our 190.8 miles per hour. Looks like a little over 3 hours. 600 divided by our answer 3.14. So that's how long the time it takes. Again, this is the key. This equation right here is the key to getting the correct vector diagram, head to tail, plane with respect to air, and air with respect to ground. It's going to give us plane with respect to ground, and then being careful with the angles in the geometry.